Hi everyone, today we're going to be talking about annuities. An annuity is a series of regular payments. Let me fill that in. So regular payments or deposits made at equal time intervals. So for example, you save $200 each month to pay for college. Another example, you're saving $500 per month for your retirement. And a third example, you pay $900 per month toward your mortgage, and a mortgage is a type of loan. All right, so let's look at some word problems together. But before we do that, we need to come up with our formula. So our future value annuities formula. So the future value, sometimes the formula has an FV or sometimes it has a capital A. So for our purposes, I like to use A. Okay, so the formula is A equals capital R, and in a big bracket, 1 plus I to the exponent n, subtract 1, all divided by I. So R is the regular payments, I is the interest rate as a percentage, N is the number of payments. Okay, so, and this is the sum of all the payments and the accumulated interest. Okay, so we're going to use this formula to answer our next question. Nick put $1,600 into an account earning 4% interest compounded annually each year for 6 years. Okay, and it's compounded annually. What is the investment worth at the end of the 6 years? How much interest was earned? Okay, so I like to write down everything that I know. So R-A-I-N. So that's why I like to use A instead of PV, so that I can have this handy little acronym, RAIN. Okay, so the regular payments are the $1,600. A is what we're looking for, so I'm going to put a question mark there. The interest rate is 4%, so divide that by 100, so 0.04. And compounded annually, so divided by 1. I don't really need to put divide by 1, but we'll do it for illustrative purposes here. And N is 6 times 1. Again, I don't need to write times 1, but we'll just do that for illustrative purposes. Okay, so plugging into our formula. So A equals R bracket 1 plus I to the exponent n minus 1 all over I. Let me just double check that I wrote that right. Yes, okay. So A is equal to 1,600 times 1 plus 0.04 is 1.04 to the exponent 6, subtract 1, all divided by 0.04. Okay, so go ahead and plug this in on your calculator. Some of you can just enter it as it appears. Others will have to work kind of on the inner bracket first, then the exponent, subtract the 1, hit equals, and then times it by 1,600, hit equals, and then divide by 0.04. So play around on your calculator. You should end up getting A is equal to $10,612.76. And then in the context of the problem, because it's a word problem, we need to have a therefore statement. So therefore, the investment is worth $10,612.76 after 6 years. All right, let's look at our next example. All right, Stacy. Stacy is saving for university. She puts $250 into an account, earning 3.5% compounded monthly each month. How much will she have in 3 years? How much interest will she earn? Okay, so compounded monthly, $250 is the regular payment. The interest rate is 3.5%. Okay, so R-A-I-N. So $250 is the regular payment. Amount is what we're looking for. Interest 0.035 divided by 12 because the compounding period is monthly. And how much will she have in 3 years? So 3 times 12, which is 36. Okay, plugging into our formula, A equals 250, big bracket, little bracket, 1 plus 0.035 over 12, close the bracket, exponent 36, subtract 1, close the big bracket, all divided by 0.035 divided by 12. So if it's helpful for you when you're plugging this in, you might want to add some extra brackets in just to kind of help you with your calculator. Okay, so again, some of you will have to figure out the numerator, then the denominator, and then divide. Some of you can just key it in as it appears. Some of you can use brackets on your calculator, and you'll be able to get your solution that way. So go ahead, plug it in, and you should get $9,474.93. Okay, again, it's a word problem, so therefore, in 3 years, Stacy will have $9,474.93. Okay, that's it for this lesson.